I've been working on a game in my spare time for the last year or so, and I've learned a lot over the last year. So I'm trying to go back and do it properly now. This is the old version of it. This is like a really old build, um, and so I figured that why don't I document some of the things that I'm doing? So today I'm going to be talking about the pathfinding method and like how I made it. And I used FlowField Pathfinding, which I ripped from Supreme Commander and one of my favorite RTS games, Planetary Annihilation. And this isn't like a how-to video. This isn't like definitive, instructions. This is just me kind of documenting how I did it. So let's get started. So a flow field treats agents like particles, and it generates a grid of vectors that tells the particles where to go to get to their destination in the shortest distance from anywhere on the grid. So these blue areas are areas that the particles don't want to be, and the black areas on here are places that the particle does want to be. So think of it as like water flowing from high to low, essentially. There are a couple of reasons why we would want to do this over regular Navmeshes. The first one is procedural generation. I'm not a map designer, so I'm going to have the terrain and obstacles be procedurally generated. The second is the sharing of resources. If we have a lot of agents all on the same flow field, they can just look for what direction they need to go rather than all computing, pathfinding stuff on their own. So this is my original flow field implementation on the old version of my game. You can see those like little debugging arrows there. It wasn't very good. If you're paying attention, you'll see that these tanks aren't reaching their destination. This one is kind of going off into the abyss. This is what happened when I brought my old FlowField scripts into the new version of the game. So as you can see, it starts off pretty good, but we start to get into the trees because my obstacle detection system kind of sucks. And so it thinks that that's a space that it can traverse, but it's really a blocked space. So first things to fix that. So first I added this little debug array of vectors to see which arrow my tank was using to navigate. Just to make sure that everything was running smoothly, I wanted to run the flow field test with some more densely packed obstacles, so that way there wouldn't be any gaps in between them, and see if I was generating good flow fields. And as you can see, my flow fields got my agent to the target, so that's a success. The current way that I'm detecting obstacles is with a raycast, which only looks at a single point. So I'm going to switch to a sphere cast, and hopefully it'll give me more accuracy in finding obstacles. There's an issue where there might be some passable terrain that I see as impassable, but I think I'll be okay. Sure enough, with that sphere cast, we're able to detect further apart obstacles more easily. The way that I generate these flow fields, by the way, is by dividing the world up into a large set of grids and then casting an A star over all the grids and figuring out which grids we need to traverse in order to get to the destination. Then I put them all in a stack and I look at the current grid and the next grid and generate flow fields between those two, giving us a start and an end destination. Well, when there's an object in the way, the A star is just assuming that there are no obstacles. So as you can see, when I put an object in the way of the normal A star path, my agent completely goes haywire. My first steps to solving this problem was to implement a debug grid that showed the Dijkstra values, showing how far away each grid space is away from the destination. So a -1 is no solution, and max means that it's a blocked space. Let's forget about the flow fields for a second and go back to the A star. So let's assume that you want to get from point A to point B, use an A star search, but one of the grids in the middle is blocked, but the A star doesn't know that. So what do? Well, there's actually another search algorithm called the D star search algorithm. The D star is like the A star search, but it updates its knowledge of the world as it encounters obstacles. So every time I see a -1, which means that there is no path, I'm going to tell my A star that that cell is blocked, and then I'm going to tell it to recalculate a new path with that information. That is a lot easier said than done, and my implementation kind of ballooned. Even though the code was really ugly, my implementation worked pretty well, and I was able to find my way to pretty much almost anywhere on the map. Or so I thought. Going back to the idea of grids, my world is divided into 4 different quadrants. There's the positive, 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 negative, 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 and negative positive quadrant. Only the positive, positive quadrant was working for this implementation. But that was a pretty easy fix, and once again I was able to pathfind successfully in all 4 directions. My last goal was one of the trickier ones. Since this is an RTS game, players are going to be able to place and destroy structures at will, so I need agents to be able to deal with obstacles that they didn't plan ahead for. The first half was easy. I made it so that if an agent touches a collider that it doesn't think is supposed to be there, it completely recalculates all of its flow fields over from the beginning. However, if the agent does not have a direct path to its end destination when it is adjacent to its end destination, it thinks that there is no solution, and it completely stops moving. I solved the problem by telling the agent to re-navigate to the nearest unblocked space, and then once it reaches that new destination, it recalculates a new A-star search from its old destination. After all of that, this thing's pretty robust. It can deal with dynamic obstacles pretty well. It can deal with different densities of these trees and different sizes of obstacles. It's really tenacious, so it'll keep going until it finds its target. It has its derpy moments, like you'll see right here. It kind of spins around for a little bit, but eventually it finds its way back to the obstacle, so I'm pretty happy with it. I don't know if this video is going to be any good. Hopefully I can make more of them. If you guys are interested in any of the things I talked about, I can go into them more in depth in future videos. But anyway, yeah.